Hello, this is David D. Hilster. I am a critical thinker, dissident scientist, and I'm here to tell you the truth about science, something university professors won't tell you, the mass media won't tell you, and certainly those science evangelists won't tell you. Well, I've been promising and myself to do this. I'm not sure how much I've been promising you verbally, but it's taken some time because I needed to get this paper into our Wikipedia, which was in LaTeX format, which needed to use NLP++ as a language my friend and I developed, and I needed to write an analyzer to do that conversion because we have literally thousands and thousands of abstracts and papers that we'd like to put in the Wikipedia. We have them in PDF format. And we are now having all the papers that we're writing today for our CNPS proceedings, which you can all look and find and buy at naturalphilosophy.org. I needed to make these translations, and I finally today got around to it. Fix the translator that takes LaTeX, goes to wiki format, and gets these big papers. Some of these papers are big, and this is the one I wanted to talk about because I'm going to talk several times on this matter. And what is that? Dark matter. Dark matter is one of those things that are supposedly exists because what we see isn't what's supposed to be happening. Of course, that's because what we think should be happening, or is because we're using what we think are the theories that should govern it. We apply those theories, and in this case, it's really two things. One, we're applying the wrong theory, and number two, we're not applying the regular theory in the right way. I'm going to explain to you that a little bit today. We're going to talk about Newton's gravitational law over dark matter, written by one of my favorite authors of the CNPS today. His name is, we call him Cameron Wong. That's his AKA Cameron Wong. It's Cameron Rigbisall. But I love his work. He's super thorough. And we're going to talk about his paper that I finally got onto Wikipedia. Of course, you can have the link there and read it for yourself. Man, is it full of equations. But I'm going to tell you the gist of it because it is real important. Well, we'll talk about that now. And that is Newton's gravitational law over dark matter. Let's read the abstract. Observational stellar movement of the Milky Way shows that celestial objects beyond 10 parsecs from the galaxy center appear to move at a speed higher than what Newtonian gravitational law predicts, and the celestial objects in the inner range at distance 1 to 8 parsecs from the center appear to move at speeds lower than predicted. And he shows some diagrams, all that stuff. It appears to a group of people that this phenomenon is a suggestion, certain failure of Newtonian gravitational laws, and the remedy, and that remedy to repair the failure is therefore needed. They mainly propose two ideas for this remedy: dark matter, or to modify Newton's gravitational law. What I actually did I'll put a link to that as well. I did a review of a new theory they call it, with Einstein's gravitational law, which is relativity, gravitational relativity, which is general relativity, and they say there is a constant, a fudge factor they can put in. They don't need dark matter. Well, in this case, what Cameron is going to show us is that we don't need general relativity either. That Newton, oh my goodness, yes, Newton by himself will explain this. He's not the only one saying that. My father has a great video on that, and I'm going to do another video on that, on dark matter. So I'm going to try to keep these a little smaller because sometimes they are going quite a long time, and I know people's short attention span or the lights at which they are stopped, especially here in Florida, only about 2 minutes, 3 minutes. Yeah, they're that long here in Florida. But anyways, we are going to talk about this particular one today, and I'm not going to get too much into any of the details because the calculations are quite intense, and there's a lot of math, there's calculus, and of course algebra. If you look down here, you've got, actually, if you come all the way to the end, you can see here, how many equations do we have? 53. And take a look at them, folks. They look scary, but I'm going to break this down for you and understand what this guy is doing. Here, of course, is something you're going to see, especially in my father's paper, or video, actually. It's a great video. You really have to watch it. And this is the speed of what we think should be the speed of the stars going around the galaxy. And what really happens, you can see here that you have this like sort of oscillating curve going on. Oh, that's the real thing. This is what is supposed to happen. Oh my goodness, we must have dark matter to make up for that difference, because Newtonian physics doesn't work out. Wait a minute, Newtonian physics does work out if you do something Mr. Cameron Wong does and my father does, and that is take into account geometry. Believe it or not, I know it's hard to believe that galaxies are not point masses. What is the point mass? It means you put a point in the middle of the galaxy and say all the mass of the galaxy is right there, and we're going to calculate that. Oh, that's going to be close enough. It'll give us. Oh yeah, well that's really great, because if we do that, then we get all these kind of weird velocities that aren't really the velocities we expect, and therefore, oh great, there's an anomaly. We can invent something. Oh, dark matter, dark energy. Oh, we can then find it, and we can win Nobel Prizes. Yay! Fame is more important, because if Einstein's wrong, who's right? You notice the question says who and not, oh, he's wrong, tell me why he's wrong. It's the same thing. It's all about fame. But let's go down here and take a look. Now we're going to just look at these diagrams, and we'll make this simple enough here. He's looking at a bar. You notice that's not a point mass. It is a bar. And that's what he's looking at. Homogeneous bar of distance d. So he's starting to calculate gravitational forces, not with point masses. And so he goes through the mathematics of that. Oh my gosh, integration. Not too bad. If you were in mathematics, it's not too bad. You take a look at it. I won't go over that today. Explain it. Now you can see he starts to calculate. Oh my goodness, from this point, what do we have? This is the center of the mass, blah, blah, blah. What are the forces of Newtonian gravity? Because it isn't a point mass, and therefore it isn't a homogeneous field, gravitational field. And so he continues calculating a little piece inside. Again, very great calculation. He's extremely thorough, Mr. Cameron. And you can see here, even getting more meticulous about where the center of mass is. The gravity, you can see, of course, there is the equation for gravitation. Newton, no Einstein, no tensor equations. So we keep going. Let's keep going down further, because we're going to get to a diagram that's going to, oh my goodness. Now what do we have? We have a cross. Now what's he doing? He's now examined a bar. Not a point mass, a bar. Now he's armed two of them. Sort of, what is he doing? He's reconstructing, sort of in a very primitive way, what? A galaxy's arms. So that's what he's doing here. You can come down further, boom, boom, boom. Here's some more equations. You can, again, use Steve Newton there, Newton's there. Now he's starting to really look at, oh, and there is a sun on one of the arms there, and with a mass, and they're going to look at that speed. Let's go further. Oh my goodness, he's now looking at these three masses at this, and what speeds they'll go at according to that arm. He's got a table here, which he looks at, and he's looking at the data comparison, showing how Newton's gravitational law can be failed, can be shown that it fails if the shape of the gravity body is not taken into consideration. That's the upshot, folks. That's the entire upshot. So he goes along and he continues to calculate. You know, look at that. He's even got, now we're starting to look more like a galaxy. See that there? And they're starting to do those calculations. All the arms and the cross consist of loose materials. Probably is that, unless the cloud is absolutely homogeneous, given enough time, the spinning cloud will sooner or later evolve into a rotating bar. What he's talking about is, he is very much a cosmologist, and he talks about how galaxies develop. It's one of the things. He's got some other great papers, just really great. This guy's mind, I tell you, blows my mind, and he is so darn thorough. So he's taking a look at this, and he's looking at how even with galaxies that don't look that look pretty homogeneous, that actually they're not, and they have those arms, and therefore, if you do all these calculations, it looks at different types of galaxies, and there we go. Typical feature of two rotational arms, and there are some object A extending those. So again, it's not important that you go through here, you take a look at this, and necessarily, if you're really into math and you really enjoy that stuff, You can take a look at this and see about what he's talking about in his paper, how it works. But he's basically saying one simple thing, and that is that galaxies are not, in fact, homogeneous. They're not point masses. Who else speaks like that? That is my father, speaks the same way. And so when you do that, you know what happens? You can start to explain those velocities with Newton without dark matter. Now, if it's the case that you use general relativity, which doesn't have a mechanism, it's the curvature of the space-time fabric, those people who actually believe that tensors are real things, whatever, if you want to believe that. Yes, if you take into the geometry, you can just have the regular equations without dark matter. Now, of course, if you have the other idea, which is, again, I'll put the link to that, and that is a new kind of theory that you have general relativity with a fudge factor, then it works. This one wins out because you don't need a fudge factor. You just need good old Newton. And according to my father, who looks into the same thing, same idea, different explanation, because we have actually a real theory with real description of what gravity really is. It's particles. Light is particles too, but they're just particles that come in waves, same particles. But regardless of the explanation, regardless of everything, I finally got this paper up here. Thank you very much, Cameron Wong. I'm going to call him Wrong because, man, I can tell why he wants to use that, because that last name of the other last names, I'm a linguist and I can't pronounce it. So there you go. But he is doing this Newton's gravity law. This is what it looks like. It is in our Natural Philosophers Wikipedia. If you are interested in helping out with it, become an editor. No, we don't let everybody come in. You know why? Because Wikipedia is the ultimate in consensus. It's in the ultimate in non-ideas that are different and dissident. Anything dissident in Wikipedia is labeled pseudoscience. That's pretty much a shame, because we don't say that, oh, PHP is a pseudo language and C++ a real language. They're different. They're different ideas, and different ideas should be even accepted in physics and cosmological theories and models. We should accept that. But I finally got to this. I hope you've enjoyed this. Take a look at it. I'll have the links to it. Guess what? Dark matter isn't needed. The reason the stars travel at different velocities because they have gravitational fields that are not point masses. They are not uniform. Ta-da! That's not hard to believe. And here's a guy who's calculated the heck out of it. And I'm telling you, the heck. I've been through it. It's quite amazing, quite thorough. So remember what I say. Don't take my word for it. Read this. Learn calculus. Learn very complicated equation if you want to know exactly what's happening. But the idea is there. You can find it. Look around yourselves. And again, I'm going to have more dark matter, dark energy videos coming soon. One of them with my father. So don't take my word for it or anybody else's on faith. Stay critical, stay thinking. I am David D. Hilster, your science therapist, showing you how to become a critical thinker. You can throw that dark energy and mass away. Oh yeah, and then there's Borkert, one of the greatest scientists of all time, philosophers of science. I'm going to talk about him too and his argument against dark matter. Completely different. It's philosophical, but it's just as right. So there's quite a few arguments against. Ciao for now.